starting. All attendees are in listen-only mode.
Good morning. Today's webinar will help attendees discover how to uncover the insights in data with rich interactive visuals enriched with machine learning and artificial intelligence, and is hosted by Brian Kelsey, Principal Consultant, and Dhruv Sethi, Technical Consultant at Edgewater Ranzel. Brian?
Thanks, Joey. So today we're going to go over, as Joey mentioned, machine learning and advanced analytics within Oracle Analytics Cloud. Firstly, I would like to start out by mentioning some of Edgewater Ranzel's credentials in the analytics and big data space, as well as review some of the industry's top big data challenges right now. And then we'll get into the technology a bit about the architecture of Oracle's cloud services, the platform as a service, and big data cloud service, as well as the advanced features embedded within it. And then Dhruv will continue with a demo showing the capabilities. Edgewater Ranzel provides services within enterprise performance management, business intelligence, as you see here, more specifically with dashboarding, scorecards, what-if analysis, and cloud migration. But we're also experienced in the big data and integrated analytics space with many of Oracle's cloud services, as well as open source technologies within the industry for cloud migration, detail offload, and clustering of services. Edgewater Ranzel has also provided some previous webinars that showcase the self-service dashboarding capabilities of Data Visualizer Cloud Service, which you'll also see today, and we'll be building on and continuing from there. It goes over self-service analytics, connecting the data sources, and creating projects and dashboards. We've also provided some webinars within BIX, BI Cloud Service, designing dashboards, as well as expanding Salesforce CRM insights. And you can see those on our website as well. Today, we'll be building off of the Data Visualizer Cloud Service webinar to talk about some big data challenges. Some of the top challenges we're seeing in the industry today are that data is in silos and scattered across many enterprises. And most of that data is locked up in petrified, difficult to access legacy systems. We've also noticed in organizations there's a lack of big data and analytical skills to support some of the more advanced platforms being provided today. And in some cases, businesses don't see a convincing business case for moving forward with an investment in cloud services or analytical platforms. And a lot of times when they do make that leap into analytics, there is ineffective alignment of big data and analytics teams across the organization. So in order to resolve these challenges, you would need to introduce a completely integrated platform that marries with a proven business focus. And that is completed through a unified data lake with smart data movement that includes managed service and analytical tools embedded within it and integrated across the platform. It also allows for agile and elastic cloud environments to easily scale your environments to handle the business and enterprise size workloads from today's data. And it also provides a unified platform for all users, from data scientists to business users. Oracle's answer to these challenges is their infrastructure as a service that provides foundational services for their platform as a service offerings. So that includes everything from data integration services to allow data providers to get data into and extract data from their data sources, from public, streaming, and enterprise data sources, and bring that data into a big data cloud service where they can take advantage of the distributed processing, machine learning, and Spark engine for Spark querying, as well as execution processes. On top of that sits the analytics services, or Oracle Analytics Cloud, which has three main components: S-based cloud service, business intelligence cloud service, and data visualization cloud service. Today, we will be showcasing Data Visualization Cloud Service. Oracle Analytics Cloud comes with three editions: the Standard Edition, which includes data visualization and S-Base for self-service data preparation, and S-Base in the cloud. Today, we'll be focusing more on the Data Lake Edition, which includes all of these standard addition features, but allows you to tap into those big data sources I just previously mentioned, as well as utilize Spark for processing at scale and give you that visual discovery of your newly introduced data lake or existing on-premise data lake. And then there is Enterprise Edition, which takes all of the data lake edition features, include data modeling, your enterprise reporting through BI cloud service, as well as some of the more advanced mobile applications day to day. Embedded within Data Visualizer Cloud Service are the advanced analytics and embedded machine learning capabilities seen here, which allows users to start with extracting and creating data, dynamically creating new enriched data sets and extending the analytic capabilities into Essbase for what-if analysis. They can then enrich and analyze that data with advanced analytics, sentiment analysis, or even apply their own scripts right from the visualization platform front end. And then they can continue even further on that analytics journey into the integrated machine learning, allowing them to create, train, configure, and apply machine learning models, as you see listed here on the right-hand side. For today's demo, Dhruv will be displaying the use of these embedded machine learning technologies with an attrition data set from a CSV file that we've imported into Data Visualizer Cloud Service. He will then create, train, and apply a machine learning model through OAC's data flow functionality, where we will then be able to show you visualizations and be able to predict employee attrition with very, very good confidence. So now I'll pass it over to Dhruv to show you this demo in action.
Thanks, Brian, for laying the ground for the demo. Hi, everybody. In this demo, we show you how Data Visualizer's machine learning suite lowers the barrier to entry for data science, allowing non-specialists to harness the power of predictive analytics. Let's begin this demo by showing how built-in explain feature assists an analyst in making business decisions in just few clicks by rapidly generating insights about values of an attribute without having to create visualizations manually. For this, I'll be working with an employee attrition dataset. This can be accessed by clicking the Data tab, which consists of a list of dataset catalogs. As an analyst, I need to understand what causes attrition in my company. This right here is a usual look of every visualization tool in the market. A list of attributes on the left, and an empty dashboard, and in this case, canvas on the right. So what do I do now? Simply start dragging and dropping attributes onto the canvas? This will take a really long time, as there are millions of combinations to work with. It's safe to assume that two different analysts can come up with completely different insights. One analyst may feel monthly income causes attrition, while the other analyst may feel percentage salary hike causes attrition. This is what we call as an empty canvas syndrome. When faced with an empty canvas, the data exploration as well as the results is based on past experience or personal bias. So how do we eliminate the analyst's personal bias from the equation? At this point, let's move on to a new canvas. This is the reason why Oracle DVD added explain capability to analyze any attribute in the dataset and explain the user various aspects of the attribute. All the analyst has to do is to point to a particular attribute, in this case, attrition, and ask the system to explain it. The explain attribute is divided into four main categories. Basic facts about attrition. What are the values of attrition and how do they relate to each other? Key drivers of attrition. What elements in the data best explain the values of attrition? Segments that explain attrition. What hidden groups in the data can predict outcomes for attrition? And the last one is anomalies of attrition. What groups in the data exhibit unexpected results for attrition? The first tab gives us basic distribution of attribute value across the data set. It also gives us a breakdown against each measure that's available in the data set. Then the second tab talks about key drivers that affect the attrition. We have now narrowed our analysis from over 30 columns to just 5 columns, dramatically reducing our problem space. We can also look at distribution of attrition over these attributes. I'm really interested in looking at overtime and job role. I can click them and review them later for analysis. The third tab talks about segments of employees where attrition rate is either high or low. That's 70% of attrition, 71% of attrition with 80% confidence occurs where there is overtime. As an analyst, I can further analyze these group of employees or start preparing a specific retention plan targeting this profile. Lastly, we identify anomalies in the data, various places where attrition did not behave as expected, and it's represented by the green line. As we reviewed, similar to the other charts, I showed I can review anomalies and select the ones that I'm interested in. Let's select the top chart. This step is important because our goal for using explain feature is not to generate reports, but it's to provide sophisticated capabilities that supports an analyst in his exploration as well as in his insights. By clicking Add Selected, we now move the selected charts onto the canvas. We moved from an empty canvas to a laser-focused canvas in just few clicks, as you see here. Also, we didn't have to drag drop random elements on and off the canvas. We utilized multiple machine learning algorithms without exposing the technical and statistical complexity to the business user. This is how built-in explain feature can benefit the business user in daily activities. Let's move on and see how machine learning can be used to predict attrition likelihood for a set of employees. In this case, we'll be first creating or training a model using historical employee information. This trained model is then applied to another data set with similar structure without the attrition information to predict attrition likelihood for employees. To train or create a model, we have to create a data flow. Now, what's a data flow? Data flows are a way to produce curated data sources that you can use to easily and efficiently create meaningful visualizations. For this demo, we are going to be looking at an already created data flow. The left side shows us list of data flow steps that can be added to a particular data flow. Since the attribute for prediction is attrition, which has two values, yes and no, we choose binary classification method to work with. Within that, we have selected naive Bayes algorithm for this example. Instead of using a pre-built algorithm script, we can also upload our custom script by adding the custom script node right here onto the data flow. We selected attrition as our column of interest. Positive class in target signifies the value of attrition we are trying to predict. In this case, yes. Train partition percent allows the user to choose what percentage of training data can be used to build the model and what percentage should be used for testing. In this case, we have chosen 80% for training and 20% for testing. The training percentage can vary from 10 to 100. We then save the model and give it a name. Saving the data flow is useful as a user can come back to the same model and fine-tune it for better results. As we execute the model, the model is created, which can be accessed from the machine learning tab. This is the model that we trained. We can inspect the model to get further details on the model quality. The second tab here talks about confusion matrix and gives us a model accuracy at 87%. Now we have trained the model and we can apply this model on another group of employees to predict attrition. This data set on which we are going to apply the model has a similar structure to the data set on which we trained the model, but doesn't consist of attrition information. How do we apply a model? We apply a model by again creating a data flow. Let's look at an already created data flow for applying a model. The apply model node consists of three sections. Consists of output that's added to the model in addition to the input columns, parameters, which are optional parameters that can pass to apply model, and includes input columns for applying a model. Add save data node saves the data set returned by the apply node. Apply node appends the predicted value and predicted confidence to the input data set and returns the entire data set that can be accessed again by clicking the data tab. Here is our the attrition predicted data is the result of our apply model creation. And now an analyst can begin diving in this data set and make business decisions. For this purpose, we have some visualizations that build using that data set, which will help you understand how machine learning works. Let's move to the Visualize tab. Right here, we have the attrition predicted data, which was created as a result of applying a model. Prediction confidence and predicted attrition were added to this particular data set. The data on this page shows only the employees who are likely to leave. The number of employees likely to leave are 41. The table next to that shows us individual list of employees who are likely to leave, which is sorted by prediction confidence, ranging from high to low. So as an analyst can begin targeting individual set of employees. The bar chart below shows us employee count by years in current role. As we see, employees in their first year in the company are more likely to leave than others. We can click this and it highlights the set of employees in the table, and an analyst can begin making decisions or start preparing a specific retention plan targeting those set of employees. This analysis can also be shared by using the narrate phase to other members in our organizations. We can even add a note. For example, Peter and Michelle are two of the new joinees who are most likely to leave the company, and a retention plan for them would be helpful. This can be directly seen by other users or other members in our organizations without having to go to the detailed process that I just went through. This analysis can either be presented in a presentation form or can be shared in different formats. Okay, so we have just taken a quick tour of how built-in explain features and machine learning models operate in OSC. These features, we also saw how these features lower the barriers to entry for data science, easily leveraging predictive analytics to tease out actionable intelligence. I'll pass over the control to Joey to conclude the presentation.
Thanks very much. Any questions about this webinar or this topic can be emailed to info@ranzel.com, and we will provide a response to you. A recording of this webinar will be available on our website shortly, where you may also find a number of previous webinars posted. We hope you gained insight from today's webinar. Please visit our website to learn about and register for upcoming webinars, and follow us on social media to get alerts about upcoming events, training, and webinars. Our upcoming webinar on April 17th provides a discussion of common cash flow problems, a detailed description of the automation of cash flow in Financial Close Consolidation Cloud Service, and a demonstration of the cash flow capabilities in FCCS. You can register for this and other upcoming webinars by visiting our website. Thank you to our audience for joining us, and thanks to both Brian and Dhruv for sharing your knowledge and expertise during this presentation. This concludes today's webinar.